Diese Konferenz wird nun aufgezeichnet.
Hi all. Yeah, recording is started, so everybody who has his camera active or will talk to me or will also be at the end on the video. It's no problem for me. Just to let you know, the video will be again published as always, and since we are already a little bit in the peak of the holiday season, it could be that we are starting the next sessions not in 2 weeks or 1 week or whenever it was planned, but after the main holiday season, because I think also because of the Corona experience for a lot of people, everybody who is able to get in vacation will take the chance now, and it's a good thing. Yeah, let's talk a little bit about possibilities. Possibilities we have perhaps not had understood so easy when we had a look at that a little bit earlier in earlier sessions. Let me try to explain a very easy implementation of a, yeah, we call it a technology. It's known in other databases called materialized view. It does not exist in the same way in Firebird in the same way, but it's really easy in Firebird to make something similar and even more flexible at the end, rather than a materialized view by declaration. So let me show you a very simple SQL statement. Select star from v_product. Okay, I'm still in my English keyboard, so I have to switch to a German keyboard. It makes it a little bit more easier to write for me and from my German keyboard from v_product. So what happens if I start that? I get the information here in my, no, it was not the one that I wanted to show you. Top 100 sales I wanted to show you. So I start this view, and the result set needs to have some data. I think most of the data is missing in that database. Let me demonstrate it to have some data in the database. The database that you see here is a FB Firebird database that we delivered together with your IBExpert installation. You will find it always in HK Software subdirectory in IBExpertDemoDB. And the database that we have here inside is the db1_30.sql. If you execute that, you will have exactly the same database as I will have it here. And you should have also the same possibilities. Let's go back to the database and let's go simply executing this statement. It does not show me data for whatever reason. I don't know why it is happening. Let me make it in a different way. We changed already a lot of things in the database, and the database was already used in prior sessions, so I think it's not a good idea to work in that database that I have already changed a lot. Let me show you how we made that. We go to the program files directory, HK Software, IBExpertDemoDB, and so on. We are doing that. And I can, for example, also disconnect from the database because that database will be automatically recreated in that moment. It's a db1.fdb database, db1.fdb. And okay, that was an error. This one needs, for example, to have the current client library file, which is in that case here automatically called gds32.dll. And I have one more simple error. So it has to recreate the database. So let's drop it manually, and we start it to be created. Okay, so what's the purpose of this database? That's the test database that we have already in use for a lot of other sessions already. And when I ran here init all procedure with 10,000 as a parameter, it creates a lot of test data inside the database. And we should now have the possibility when we disconnect and reconnect to the database, and we do the same top 100 sales, we see the amount of data here on our screen. Let's go to the performance analysis. We see here at the moment that it was doing some operations on several tables. On the MV table, I will explain that a little bit later, and we top 100 sales, order line, and product table. And here were a lot of SQL statements. Let's start the same SQL statement again. And let's go back to the performance analysis. And that's really interesting at the moment. When I started the second time, the create analysis the people, I have to think about your question. Wow. I call you Raphael. It's okay, I think. Sorry for joking about the name, but let's show you a little bit about what's happening here, because you see exactly the same results as you have seen a little bit earlier. And when I execute that again, and I go to the performance analysis, now it will be recreated with all the individual data with a lot more operations here internally. And when I start it again, it will be again here on the second step, and one more time, only 100 non-index reads are made, and performance analysis shows us that's really a very simple implementation. And basically, it's a kind of a report. If you have, for example, something that is shown inside your database, and your database, for example, inside your database application, and your database application is, for whatever reason, a very complex basic information on the starting screen, it's not always a very good idea to have the starting screen doing a lot of SQL performance-based operations already. Sometimes it's a very easy way to avoid that. And I show you much more easier how easy it is inside Firebird database, and why sometimes the SQL statement does more as it does now, and sometimes it does not so many operations. So it's not really a random situation, it's a really easy to understandable situation. Let's have a look at the basic implementation. As you can see here, perhaps the V underscore is my typical shortcut for a view. And the view is really simple. The view is really a combination of a named SQL statement. So a view is basically nothing else than the following. When I go to a SQL statement, I can replace the view name, brackets open and close, and I put the same statement here inside, and I see the same result. So that's basically the implementation of a view. The interesting thing on a view is basically also not only the possibility that we can, for example, name something as part of a SQL statement to be its own SQL statement. The Firebird server does a really good job to optimize all these configurations and all these informations together. But what the view is also really easy to be used later, and we will show it in an example also later. A view is not only a stored SQL statement somewhere inside the database, but the view can also have triggers. And that's one of the really interesting ways how to improve your applications and also the speed of your applications. But what you see first is the basic idea behind that view, because that view is now a SQL statement, and the SQL statement is doing a SQL select statement on the MV top sales interface, whatever it is. And when we have a look at that object, we see it's a stored procedure. And this stored procedure allows us a very simple way to do some kind of emulating a materialized view. Let me explain what I implemented in that demo database. As I said, the demo database is part of the IBExpert installation, so you can have a look at all the source code on your own, and you find everything implemented also inside your demo database. So any procedure can have return values. So we have two columns, a title and an amount. And the basic idea behind that is extremely simple. We have a select statement. MV. What is MV? Let's have a double click. MV is a simple table. In the MV table, we have nothing else than the view name and the last update for that view. So it's a very simple way to do so. So let's go back to the stored procedure, to the interface stored procedure. And the interface does not have anything to do with interfaces inside Delphi or Pascal language or whatever. That's definitely not any part of the problem. The MV last update is simply an interface now given to the procedure, and it internally gets the last update value from the table into a timestamp, does a check if the timestamp exists. If that is a null value, it has to, for example, take the current timestamp -1, so yesterday. But if the timestamp is older than 1 minute, -1 minute based on current timestamp, in that case, it will execute the MV top 100 sales update, and that's a procedure. And it will also update or insert into the MV table the materialized view or the name of that current SQL statement together with the current timestamp, and also do the update or insert based on the matching of the view name. So that part is always done only every minute. Let's have a look at this MV top 100 sales update procedure. What happens here inside? It will try to delete from the MV top 100 sales table. Let's have a look at that table. It's nothing else than the result set that I want to have for my application, for my SQL statement. I just want to have the full result set inside a physical table, and it has exactly 100 records. So if it has to update everything, it will drop all records from that table, and it will insert all records to that table again, because it is simply doing an insert into select first 100 product title, sum, product quantity as amount from product, join order line, and so on. The interesting part is also when two people at the same time try to execute the SQL statement on the view, Firebird has the capability to simply ignore a deadlock. Because when two people will operate at the same time based on this update procedure, they will run into a deadlock, at least here in the delete from top 100 sales or so. And it will immediately run in that line when any do begin ends. It's in exception handling inside Firebird. And you can use it inside a stored procedure or inside a trigger. And whenever it is going into an exception, it will run into the when, any, or when SQL code, or into the when operator. People who are familiar, perhaps from 30 years ago with BASIC, have a similar way to do exception handling, and not the try except or try catch from modern languages. But the interesting thing is, whenever we are starting this procedure, it will try to delete all the record, it will try to insert all the record, and if it's some deadlock available or some deadlock happened on that procedure, it will simply ignore that case. In the next step, it will try to update the view name. In fact, to make it a little bit more perfect, we should take away that part and put it here into the procedure again also. So that would be the proper way to do so, because in the old implementation that you have seen here, that we will execute the procedure and we will later update the table, we would have the deadlock a little bit later. But the most interesting thing is now really easy. Whenever I try to start to do the update here on that procedure, in that moment, we put everything that is writing the data into a second procedure. And whatever happens to the second procedure, we ignore any deadlock that can come up on the second procedure. And we will now do some code review, make code a little bit smaller perhaps. So that's really nice. Let's put the then here on that line to see that this will happen automatically. We could also do some optimization in these two lines here, but that's not really the important problem. The basic idea, what this MB top sales interface procedure will give now back, is the first step is simply getting the information, which is the timestamp for the last execution. If last execution is older than 1 minute, I will try to update the data. But for whatever happens, if the update of the data is successful or not, I'm not interested in that, because I can also display 2-minute-old data or 3-minute-old data. That would be no problem at all, because they are still, active enough or new enough for the operation here. So let's have a look here at my MV top 100 sales interface, and let me show you what happens if we are going here to the data, and whenever I see the data from that table, I will see the informations. And let me show you within a second database what happens if two people will try to execute the operation at the same time. So let's have a look here at my first SQL statement. Let's go to the last statement. Select star from V top 100 sales, execute and fetch all, and I see in the performance analysis it does not have to do anything because the current data is already early enough or new enough. Let's go back to the second IBExpert, and we will have the same SQL statement. I have to put some space here on my screen. I will do the execute and fetch all. And as we see here, we have now also the 100 inserts, 100 records updated or deleted from the operation. We see here directly that the writing process was successful. And when we go back to that procedure, to that statement, we will see that it will try to do the select statement on the MV. It will show us that it's not older than 1 minute. And even that it is a little bit older than 1 minute, we can wait a little bit more. We can later see that this one will not be able to execute the procedure, the update procedure, because it will not be able to update the MV timestamp already. It will, in that case, it will not already work, and it will also not be able to try to find out that the data is already too old or so. We see here something that is a little bit interesting. We have 101 non-index reads already. That's a little bit different here. And we also have here still the information inside our view that we still have the data. The data does not change at the moment, but in a lot of big enterprise applications, when you have a start screen and the start screen shows very complex data, for example, current orders from customers with working times on everything, it's often good to have your application show most current data, but they do not have to be exactly from 1 second ago. It's often a very good way to make the work on the Firebird server much easier for the Firebird server when you simply try to avoid that the individual user will operate on his start screen already a very complex amount of data. And it happens in enterprise applications even more, when people in the morning at 8 o'clock a.m. or so will start working, and 100 people will start their application, and 100 multiplied by the amount of operations on all the tables will run to update the data. Everybody of those 100 people mostly will have to wait for the result, and nobody's interested in that. And the interesting thing is also that what is also possible, when we have, for example, someone who has to update the data, as we can see here now, here below, we see this one has already updated the data. And whenever it will happen, we will re-update the data whenever it is older than 1 minute. But this one will not be able to do the update because this one is still having the old active, the transaction active. Let's wait until the first minute is over. And whenever the first minute is over, we will see again that it will operate again the update procedure. And I will, in the meantime, I will try to update the procedure again from here, and this will not work, but this can work within 1 minute. I hope I did not over. Yeah, now 1 minute is over. This one is now again updating the data, but it's not blocking the data from this one because the blocking writing operation is handled by the view. The view is calling a procedure. The procedure is a more or less reading procedure, which executes a writing procedure. But the writing procedure does have some when any block. So whatever happens with the writing, it can be simply ignored if we are going into a situation when we have a deadlock inside the database. So that could be a very interesting way also to implement much more complex operations inside your database. And whenever the first connection here now is stopping and we are starting to run the statement again, we see here now this one is responsible for operating and inserting the new data. And that was the SQL statement that I wanted, because I didn't want to have the SQL statement executed the update procedure every time. I just want to have it to be executed every minute. And you can also do some kind of server-based operation, because when that is, for example, part of the start screen of your application, at that moment when you have the start screen of your application, the update procedure must not be executed automatically by this view. It's just for demonstration reasons that we do that. We could also remove that part here completely and simply operate this update procedure on a server-based operation. So for example, every minute or every 2 minutes, we simply execute this procedure, and everybody who wants to see any of the detailed data will then directly have a look at the table and not at the individual table, because the individual table is based on this statement. As you can see here, for example, this is the official part that is executed by the update procedure. And anytime we are operating that, we have here now 35,000 and 35,000 operations. And in real-time database models, it's sometimes much more complex to get the result set. And when you have a look at the performance analysis, just for starting your application, it's always a good idea to have, for example, the first step when your application is started, or you start your application. When it is already started, have a look at the services and at the services database monitoring, and then at the attachment. And let's have a look at the attachment ID when we go back here to the second database and we update that. We see now here an attachment number 15. And the interesting thing here is also really easy to understand. We have the 15 as the attachment ID. And when we now go to the Trace API, and we have a look at the Trace API session inside IBExpert, we can start a new Trace session. And we have here a possibility to monitor in the Trace API only the attachment number 15, or whatever attachment ID you want to have there. And when we say OK, we just have to say here some additional information, like this one is now this one, and this one is master key. And we simply write here down number 0. We make here some changes. Maximum length of secret strings locked, 8,000. It's a little bit too short. We have as a default 300, which is really short for a secret statement. And then we can say here, save the config as default. We did that. And in the next step, we switch back to monitor only session with attachment number 15. We say OK. And in the next step, we simply have a look at what happens when I, for example, execute my SQL statement. And the SQL statement was that statement. And we see exactly what happened here internally. We see here the one record was updated, 100 records were deleted, and so on. And when we have a look at the session again, we can stop the session and we can directly go to the grid view. And in the grid view, we can use Control and plus on the num block, and we can have a look at what happened technically while I was executing that. And here you see the individual statements. So that's also really interesting, for example, to understand what happens inside your application, what does your application. And when we have a look here, for example, at the individual timestamps, we can order this by this column. And we see here, for example, that this one is responsible here for the 100 milliseconds. Select from top 100 sales, and all the individual operations can be found here internally. And that's really helpful to understand what happens technically inside your application. That's important to know. That's basically the basic idea is really simple. A materialized view is more or less something that you can use to store the data. And when you know the concept, for example, of Oracle or other databases, the materialized view is more or less mostly done by declaration. So you would say something like create or alter view or create or alter materialized view stored by blah 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 on update on commit is, for example, a possibility that we know from Oracle, or on demand is a possibility that is also possible from Oracle. The interesting thing is what you have seen here is really easy for you to implement yourself when the data is refreshed, and that the data is not refreshed by multiple instances at the same time. Let's talk a little bit about a story from the real world. It was an energy, big energy company somewhere from France, where we did some work for, and I think it was 3 or 4 years ago. And we were doing a lot of data, transmitting the data from a local Firebird database server, which is where the truck will wait for the for an energy power station. They were burning wooden parts, parts from wood, and they simply were getting approximately between 40 and 50 trucks every day on that plant. And it needed to be evaluated if it's too wet or too dry or whatever the problem could be with the material. The interesting thing was that we had connect to a local Firebird database, which was responsible for getting the information from the employee who decided if its material is okay or not. And we had to update the data into an Oracle database approximately 500 kilometers away. And we had a more or less slow connection to that database. But we used a very simple script. We used a IBEC create connection with CT ODBC to the Oracle server. And we used a second connection to the Firebird server. And we used that script to select on the local Firebird database and put the data into the remote Oracle database using the ODBC driver. And it was really a very easy project. Even that we had at the end, I think 64 tables or so to be transmitted over to the Oracle database. We had made the full project within 2 working days. So it was really easy based on the IBExpert technology. The interesting thing was our script was running and transmitting the data every day, approximately at 12 o'clock in the night. The data was transmitted to the main company side, and it was no problem for at least 8 or 9 months. And from one day to another, they had some emergency call to us. Our software was responsible for blocking the full Oracle server, and nobody can work because of our software or our script or whatever was responsible for that. The interesting thing was we received the call from the manager. We were asking for a real report. What is the problem? And they were showing us a screenshot from Oracle system that was showing too many execution on materialized view. And we said, okay, too many execution on materialized view. We did not change anything within the last 8 months in our application. It could be that somebody has changed anything on your side of the Oracle database, and perhaps he did that within the last few days. And they were always answering, no, nobody changed anything, and so on. But I saw already on the screenshot with the error message that that was definitely some object involved in that problem that we did not had a few weeks ago or the full month ago. And we were asking for somebody who's responsible for programming the database on the Oracle side. Interestingly, there was some kind of Oracle specialist who was responsible for that. He was a complete idiot, but that's a different point of view, who declined to be responsible for that. And he's directly said there must be something in your script because we did not change anything. And I said, okay, no problem. I still doubt that you have not changed anything because that is exactly the same technology we are using a very long time. He said, okay, perhaps it could be based on the view that I changed last Friday. And I said, interesting. You changed something, and a few minutes ago you said you did not change anything. Okay, now we are in a kind of a management decision who we can charge the money for our work. The problem was he simply created a view with some access to the data from the tables that we inserted into their Oracle database. And he used something in Oracle, which is a materialized view. And the materialized view in Oracle has the possibility to work with the on-commit attribute. And the on-commit attribute simply does a recalculation of the view on every commit on any of the tables which are included into that view. It's a really stupid idea because we had the operation overnight sent to the Oracle server, committed approximately, I think, 10,000 times per night, because we tried to have as much possible data already transmitted to the other side because the connection was not very fast. And the interesting thing at the end was that we had a very good reliability of our application in that moment until they changed or they added this kind of view. And when I really have no clue about real detailed information of what is possible in Oracle, but I know the concept of materialized view. I know the basic stupid idea of having an on-commit materialized view, and I simply said to him, please change that view from on-commit to on-demand, which is the second implementation. So anytime you want to have a view, in that case, refreshed again, you have to say it to the Oracle system, and it does not do it on 10,000 commits every night. That problem was solved within minutes, but the Oracle specialist was really a stupid idiot. You cannot say it different. But I know the company who ordered the original order from us is no longer in business, so we will not have any problem to talk about that. But that's not because we were responsible for them getting out of a business. They were really definitely responsible for that on their own. What is the basic idea to talk about that? If you see something that is technically implemented based on a kind of declaration, it's not always the best thing to do it in that way. It's exactly the same also inside Firebird. Sometimes Firebird allows you to do things which could be interesting, could be an interesting, easy solution for whatever you need in that moment. But sometimes just have a look at solutions around you, and you will definitely see that there are completely different solutions for the same problem. And you have perhaps a much better implementation on your own rather than having only the possibility to do the declarative way. One of the things we also sometimes report to customers is that really complex databases, and really complex database does not mean 100 tables or something like that. We have customers with a database with approximately almost 3,000 tables in the meantime, and a lot of indices, a lot of foreign keys, a lot of primary keys, a lot of stop procedures and triggers. This database I was talking about is in German language, an ERP database system. And it's approximately, I think, 50 or 55,000 objects inside the database. Perhaps in one of the future sessions, I will talk to you about that. So we see here approximately 3,000 tables. We see approximately 2,500 views. We see approximately 10,000 procedures. We see 15,000 triggers, I think. And indices are, for example, almost 20,000. So extremely complex database. The big problem is, in that case, for example, that if you are open that database from a client application and you do a simple prepare of any statement inside your application. So when I simply do the following, I will go back to my statement here, for example, this one, and I simply do a prepare. Prepare is the following. Where's my prepare? Here's my prepare. So prepare query. What happens when I do the prepare? In the prepare of a SQL statement, the Firebird server internally does a lot more than you think, especially when you do it the first time. And in that database, we have one big problem at the moment. When we are doing a prepare on a specific table or on a lot of these 3,000 tables, it will go to all the dependencies inside the database and will prepare all these foreign key relationships also. And since they have used approximately 10,000 foreign key relations between their tables, some of the tables, for example, the product table, have so many foreign keys to so many tables, it's extremely complicated for the Firebird server to prepare any access to the product table in that database. And in a physical perspective, we see in that database that a prepare on any statement consumes for this client application, approximately for this client connection, approximately 500 megabyte of RAM per user connection. And if you have, for example, this application implemented for 100 users, or one customer of us is using that application with approximately 250 users, you need to have already 120 gigabyte of RAM just to be able to open that databases from all these clients. One of the reasons why this happens is, and I was talking also to some Firebird core developers about that, some of the reasons why that is technically done, the tree of the objects and the sub-objects and sub-objects and so on are often prepared automatically because you have no chance to interrupt that. And it's a one-time statement, but in that problem, in that application, we see, for example, that the each user connection needs approximately half a gigabyte of RAM, even with the Firebird Super Server or the Super Classic Server or the Classic Server. And the problem is that the first prepare statement in that application takes approximately 20 seconds, even on a fast server. And that's really a way to think about your application. If you have, for example, an application that is using a lot of primary keys, foreign keys, especially the foreign keys relations to a lot of tables, it could be a good idea to not use the technology, which is the good and easy standard technology. For example, that the product table has some dependencies. Dependencies of the product table is, for example, that the inventory table has a constraint called a foreign key to the product table. That's really easy to find out. But if you would see, for example, here in the dependencies, when you're going to the table data, and you see here in the dependencies not 4 tables, but 400 tables. It could be an interesting idea to think about the following idea. Replace the foreign key by a trigger that you write on your own. Because a trigger that you write on your own is completely differently handled rather than a foreign key relationship. The prepare does not do so many stupid things just because you have added a trigger, but technically it does exactly the same as you can do with your trigger, but there are a lot of possibilities to improve the general speed of applications rather than using everything by default declaration. So it's always a good thing to think about that. But if you are working in a database with perhaps 1,000 objects inside the full database, 1,200 tables, 200 products, 200 indices or whatever, do not even think about replacing foreign keys by a different technology. But if you are somewhere in the thousands of objects in each category, it's sometimes better to implement that in a different way, because a foreign key and the primary key relation cannot be deactivated so easy. If you want to deactivate, for example, your foreign key trigger implementation, it's a much easier way also to implement some code inside your trigger, for example, that a specific user can also work inside the database without any foreign key primary key checks. What you can also do with the views, the view to have, for example, the basic idea, as I said here already, the basic idea behind the view to show some data to a user and to show the data to a user which was perhaps created based on a stored procedure, update procedure, as you've seen here today. You can also do it in a different way. Let's have a look at the product table. And let's have a look at the product table based on a very strange idea. What happens here in the product table? We have a product table, and the product view is simply showing the data from the product table. So the product table has here, for example, category ID, title words, actors, prices, and special. And the view internally does the following. The view is now again a named list of result parameters, or result columns. And this one is now a set of SQL statements. So what does this SQL statement technically do? It shows every column of the product table, and it will create here a own column based on a select statement, a subselect inside my database. So when I have a look at the data, it's really easy. I see here the stock amount in stock on each table. The interesting thing could be that if you have to do some inventory update, in Germany we also use the same word, inventur. Inventur is every start of the year you have to count everything that you have found somewhere, and everything that you did not found will be set to 0. Let me show you how it is implemented here and technically how it is done. Even that you see here this column to be a select statement, and I go to data, I am able to change the data and commit the data. And the data is now really written to the database because we have now here a new value. How it is done technically? Definitely not done based on the select statement, because the select statement cannot be able to write data. Technically, the view allows you to create triggers. In each moment when you see, so for example, some data, you can do an update, you can do an update, insert, or delete. You can also do a select on any view. What happens if you do a writing operation like update, insert, or delete? In a non-triggered view, it will not allow you to do so. In a triggered view, you can have a before insert trigger on the view itself. So it's connected to the view. And technically, it does nothing else than simply doing the insert statement here into the product table. The delete statement, the delete view, is also really easy. Technically, you do the delete from the product where ID equals whatever. The Firebird server internally knows, okay, he's doing a delete. He's doing a delete on a view. I need to use the trigger for this delete, and technically implemented it is in that way. The even more interesting implementation is now the update trigger. Let's have a look at the update trigger. So the update trigger, any trigger is created by create or alter trigger, v product bu for whatever object. So you can create a trigger based on a table or on a view. It can have exactly the same before or after, active, non-active, update, insert, delete, exactly as you know from any trigger. And the interesting thing is also you can use the columns of the view in new and old informations, also like you know from any other table. If new stock is not equal to old stock, so let's have a look at our view data page. I change the stock number and I change, for example, 555 here, and I go out. So what happens technically? Technically, the view is operated by Firebird. Firebird detects, okay, there is an update view. The updatable view technology is implemented by a trigger. It runs a trigger. It detects, okay, new stock is not equal than old stock. Amount change is calculated based on this formula, new stock minus old stock. And then we are executing a procedure to change the current stock value. What does that mean? Let's have a look at that procedure, the change stock procedure. And the same change stock procedure is implemented like a classic procedure. It's not really complicated. So we are just getting the information from inventory, which one is the inventory, the first inventory number, the first inventory ID from the inventory table for the current product. We will have a look at the current amount of quantity in stock. We will update on the first inventory the new amount, and we will delete every other inventory amount on our database. And if we have here an exception, we will run again here some possibilities, simply for demonstration. We are simply putting insert into inventory a new amount. So when we have some problem with writing the data from the view, it's still a possibility to do so. So the interesting thing is now really simple. When we have a look at the view, at the V product view, and we have a look at this table, for example, we have the product ID number 2. Let's have a look at the product ID number 2. We go to the inventory table. In the inventory table, we have the product ID number 2 in that column. At the moment, we only have one record here, for example. If we add a new record for the number 2, we have here, for example, 100, and we have another one for the number 2. We have 1, 1, 2, whatever. So completely different values. And we go to the V product table. We go to commit the record. We see now here the new stock value. which is combined all in all 3,400 whatever. And when you have applications which have concurrent updates to a stock, the number on stock, it's always a very important way to do it in a proper way, and not do it like you always think that you only have one user inside your database environment. Especially later inside a enterprise application, you have to think about completely different that. So, for example, if you order new products, but on the same moment you sell existing products, you cannot simply do an update on the number of products in stock. Sometimes you have to do a plus value, which is added to the individual numbers, and the minus value, which is now added to the exiting numbers. So what happens? What we technically show you here, we simply write down now, for example, 999. We switch back to the next record. 999 is now operated by a trigger. Trigger is executed. Trigger is executing the procedure. I commit that. The writing procedure is now doing exactly what I showed them. And when we go to the inventory table now, we see here now the number 999, and we have no longer any other record here inside my table for the same product ID. So since we are doing a lot of inserts or updates or deletes in a very specific way, especially in larger projects where we do not have the possibility only to do updates, sometimes it's really important to show data like the number of products in stock here as a kind of a live calculation in runtime, and have the possibility to write back a replacement number, and whatever that means, we can directly write it back using a kind of a view. And the view is extremely simple to be done. Let me show you how we can create such a view. Let's create a customer view, and especially a updatable customer view. You see here 20 columns. So if you want to write it on your own, that's also perfectly fine. But when you're using IBExpert, just have a look at the Create View tool button. And the Create View tool button is simply showing you the wizard to do so. You get an automatically created name, VW customer, and we can simply click here on before insert, before update, before delete, and everything is created automatically. You can also do some additional informations here, select some data or so. But let's have a look at the before insert trigger, which is created by IBExpert in that moment automatically. At the before update trigger, which is created automatically, and the before delete trigger, also created automatically. And when I compile that, we have also now the possibility that we work no longer on the real table. We can, for example, now work here on that view. And the interesting thing is really easy. Even that I'm working on a view, I can write down data, and the data is now sent to the table using the update statement from my updatable view trigger. And the updatable view trigger can do, for example, a direct update on the individual tables, or it can do call some procedures to do so, and so on. What is also really interesting could be if you have, for example, people only from Ohio that should see that. We can, for example, add in the view a specific information where state equals OH. And we have a view here. And when we commit that, we should now only see any longer the data from the state of Ohio, as you can see here. And we can also do that in a very different way. So if you need, for example, some information, and these informations need to be a list of records which are not given by a specific list of, for example, zip codes or something like that. It is really easy to do so because this expression here could be really easily also implemented using a stored procedure. For example, my current user is the user sysdba, but when my user is, for example, the user HKL or something like that, in that case, I will show him a different amount of data, a different state, or the states where he has some additional rights on to see that. And in my view, I can do, for example, a kind of a procedure, or I can do it also in a technology which is also possible in Firebird 3 now, in a new function. And I call this function, for example, visible. And I simply say state varchar 20 returns char 1 if state in OH FL, then return true, else, make it different, DCLB char 1, just to make it a little bit more easier to understand. Then V equals T and return V. So let's have a look at that. Need a closing bracket here. So now we have, for example, a visible function, and where visible state equals true. So now let's go for a disconnect and a reconnect to be sure that we see only the current data. As you can see, we have Florida and Ohio inside our implementation, and only they are visible. And that's really now a very easy implementation, for example, also to improve the function. It's technically also possible to do the same with a stored procedure in Firebird 2.5 or older. But with that function, it's much more easier to be readable. We can, for example, also say if current user equals this DBA or something like that, then if state in New York, it is also visible. So let's have a look after a reconnect to the database, and we go back to the customer view, and we see New York, Ohio, and so on. So that gives you also the possibility to implement a kind of a row-based filter based on the user that connects to the database. And you do not have to show everything to everybody, because in most cases it makes no sense. You can also do some additional functionalities. For example, we also have the possibility here to get, for example, a first 100 or something like that. And this value can also be a result of a function. I think it should be possible. I do it the first time, but I will try to do it. Rec number or something like that returns integer, and we simply say returns 100. Very easy implementation. And when we do this here and we implement that, we typically get an error message here, but that is only because of missing brackets. You have to know that anytime when you need a first or skip statement, you also have to understand that the value that is coming there behind that, also when it's a variable, it can always be a variable, it must not be a constant, can also be a function, as you can see here, but it needs brackets behind, before and after the expression. That's also really important. And when we now have a look at the data tab and we do a reconnect and connect, we go back to the data tab. We see, for example, also 100 records. Whatever amount of records you need to have to be displayed inside your application, especially in enterprise environments, you will definitely see in the requirements that nobody will show you every record. And if you want to learn why, just have a look at your Google starting page. And when you're Googling something, you also do not get the full result of the internet. You simply get 10 records back or whatever amount you have defined inside your Google configuration, but you never will get back any result set. And a lot of Delphi programmers often do not understand the problem behind that, because the problem behind that is extremely important. If you want to see and understand the problem behind that, let's go back to the old video that we have created, where I was showing the TCP IP expert, where you can directly see on the network protocol what is transmitted over the protocol. And there you will see that much more is transmitted over the network protocol. But if you have, for example, a secret statement that shows the first 100 records for whatever reason to a result set, it will only transmit 100 records and no more byte at all. If you want to see, for example, in the visible function, new records, or you want to have the new function that we have implemented for that, the record number should be perhaps also differently. If current user equals this DBA, then return 100, else return, for example, 500 or something like that. It's also no technical problem. In that case, we can also do, after a reconnect and connect to the database on the view, on the data, we will see that we now have 500 records because of that situation. So some very basic informations can be done in that way also. And let me show you one also very simple way to hide some data in runtime that are physically inside the table, but that might not be always visible for anyone. So let's have a look at, for example, here at the credit card column, for example. And let's make a very stupid implementation. For example, a CC visible and CC varchar let's do it 20, 30, whatever. It's not such a big problem. And we also want to give back a varchar 30 on that. And if CC starting a very stupid implementation, as I said already, with 1, then return CC as return an empty string. Return. And we do the following. We are simply doing a select statement here based on our credit card information, CC visible. We are simply implementing here such a function for the amount of data. And when we go back to that part of the data, we have a look at the data of the customer view. You see here a lot of non-existing credit card informations, but technically they are there. We can also do now, for example, a kind of a shortening of the credit card. For example, we do, for example, here not the credit card visible function. We simply do the let's do the return CC substring CC from 1 to 4 with a lot of spaces to make it look like a that should be still there, and substring CC from 1, 2, 3, 4, 5, 10. Try this one. Could be possible. Substring CC from. Let's do it in that way. That's not 2, it's 4. Sometimes I'm just too stupid. Let's disconnect and reconnect again. And when we have now the view customer, the data, you see here that we have some kind of shortcut on our credit card number, whatever it at the moment means. What we are doing here, I think it could be number 16 would be a little bit better. I just want to show you a kind of a row-based filtering, column-based filtering, and all this can be done easily based on the technology that we have here inside our Firebird database already, and which gives you a lot of possibilities to hide data from the real user, and to be sure that, for example, some sensitive data like a credit card number is not visible to anyone, but it's only shown in part of the basic informations, as we can see here now. But we can, for example, also do now here a 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And if I commit that, and we have a look at that, we will see that it was written directly to the database, but it's no longer readable at all. So also a very good and easy way to work inside your application, and your application can now directly write data to the database, but it does not have to show anything to the end user, to call center agent or whoever is responsible for that. But he can see enough of the information for this specific task. And I think that could also be really easy to understand. And as you have seen, for example, the row-based filtering is now here also done based on that view, based on the where column here. And the column-based filtering is more or less done based on the function CC visible function here. And this kind of functions make the SQL code really easy readable. And you can also do a very complex information based on that. One of the also really important things inside Firebird is that the specific user, for example, a specific user that we add here in our database, for example, HKL, will be, for example, allowed to work on that database, but we will give him only rights to that. We will go here to the users, and we will give the user HKL rights to the view. Let's sort it to the view customer to be selected, update, delete, insert perhaps, and nothing else. Let's try that. We clone registration info and we call it here HKL. And when we open that database and we try to open, for example, a specific table like the category table, we will get an error message because we are not allowed to do so. But if we go, for example, now to a customer view, we see the real data. We also see the specific credit card information. And when I try to have this credit card information, for example, 123, 123, blah, 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 whatever implemented here, I can also write it back. And I see also here my data, which is written back to the database. But when I try to get to the customer table itself, I do not have the rights to do so. So that's also one of the possibilities that's already built inside Firebird. You can, for example, hide data from the end user based on the rights of all these objects. And you can make any GUI application much more powerful simply by letting the Firebird server itself already decide if data should be visible or not. Especially on the row-based information, it's really interesting. For example, if you see every time on every result set only 100 records and not 1 million records, every DB grid somewhere inside your application will not consume so much memory. And it will allow you to work in a much better performance over the network protocol, but also inside your local application. And always have in mind the basic idea of Google. You write something inside a search column and you get a result set, but a limited result set. You do not get everything. So if you are working, for example, on a table like the customer table here directly, at the moment I'm again the user of this DBA, it's allowed to do so. And I go to the first 35 records and I want to see, for example, how many records are available. It's it's not the real case for an enterprise application that I have to display 10,000 records inside my DB grid, even if it's technically possible, but it still makes no sense from my perspective. To implement, for example, a level between a specific data table and a specific implementation can also be really easy, because the view can also be used if you want to change, for example, in the future, your existing table structure completely. If you have, for example, the basic idea that the special column is no longer implemented here inside the table, but it's in the future, for example, a part of a foreign key or something like that. In most cases, you will simply have to check out where is this special column technically used somewhere inside the database itself. So if we, for example, have a look here at the field dependencies, we see a lot of objects are using that. The init all procedure is using that, the v product is using that, product bi is using that, and so on. So in that moment, we can find out how many objects we have to change, or we have to, in these objects, we have to remove the special column. And it might be a good idea to understand in that moment that the special column, when it's in the future inside a external table, which is only connected based on a primary key, foreign key, or something like that, in that moment, it could be a very interesting idea to have an interface to all parts of your application, which can be, for example, divided into two tables. Let me show you the basic idea how that can work. We are going to the customer table, and the customer table has a lot of references to other objects. I will do it perhaps in a. I think I would try to do it in the product table because it makes it a little bit easier. Let's think about the product table should not have any longer any of this relation. So we have a view, two views, which are showing to the table. We have a start procedure, and we have here a index and one more index. So what happens technically when we are when we want to resolve all the dependencies? At the moment, we have a lot of foreign keys, and a lot of foreign keys simply means when we go to the that's not the message I wanted to have. I have to restart IBExpert. Does not responding. It's already a little bit too hot in my office here. So the basic idea that I want to demonstrate you, we do not have the full time to show it, but the basic idea that I want to talk about is how to get the informations when we have, for example, a table like the product table, and we want to change the product table to a completely new table. Example, we want to have a insert into product v2, select product. IBExpert allows you to do so. Just give them a new table name and doing the select on the existing table, and it runs extremely fast. And we have, for example, a new table v2 for whatever reason. We have in table v2 now almost exactly the same implementation. What we do not have is in moment one, when we do it in that way, we have to use the not null possibilities on the primary key column. but that's really easy to implement. And we have to do the constraint manually. It's not done automatically. It can be done automatically in a different way, but I just wanted to show you how it is working at the moment. And we have a product v2 table now that is a replacement, a new replacement of the existing product table. Let's go to the product table and let's go to all the dependencies of the product table. For example, customer history. That's really interesting. Why does this happen all the time? Customer history. It's possible. Customer history has, for example, several constraints, like a foreign key to the product table, as you can see here. Let's drop that because it should no longer be, let's go back. I will do it here in the product v2. We do not drop that. We simply change it to the new table. So that's a possibility. And let's go back to the product table, to the existing dependencies. Next one is the inventory table. Inventory table has a constraint, foreign key, should now be constraint to v2. And refresh that. Order line. Dependencies, constraints, foreign key, product, v2. And next one is the reorder. Constraints, foreign key, product, v2. So now all our foreign keys to the product table are already changed to the product 2 table. My view, the product, is now also changed to use v2. And this one should also be v2. And we have here now the remaining stuff. How to change, for example, a name more or less globally. It's also not such a big problem because we know here, for example, a lot of procedures and a lot of triggers will have the product as a name inside their existing code. And what we can do, for example, is a very simple way. We do the tools extract metadata. We export everything to script executive in that case to show it to you. Every procedure and every trigger should be exported. And we also say it always should not use, for example, the create database. It should use the connect database statement. Include password is okay. And it always should use the create or alter, because in the next step we have to execute the script. And what we do here technically is really simple. It will connect to that database. It will go to the create stock. And everywhere where we have written now in procedures and triggers, product should be replaced by product v2. And everything is now renamed to product v2. Let's go back to execute that. We disconnect that. Table unknown, v product. These triggers that are based on the views are not executed because there is no view product v2, but that's not a big problem. In case you have a problem with that, it's exactly the same here. The product on the views are not existing, so these error messages can be ignored. But if they are not to be ignored, just click on the right side, copy erroneous statements into clipboard, and then you can put it here again into the script executive, and you have the error messages and also the statements that are not working. And you see here everything is based on a view product v2, and the view product v2 does not exist. The interesting way is now we have everything removed from the dependencies here. We only have here the original trigger on the v2. That one is now also removed from that dependency, and this one should also be v2. So let's have a look. We have no longer any dependencies in my table. It's a kind of a, yeah, more or less migration of the existing database. And now I can, for example, do a drop on this table. So I simply drop a table. And I can, for example, now do a thing that is also really often an interesting way when you have, for example, existing old software that has a lot of hard-coded SQL statements. It is sometimes a very interesting way to do what I do now in the next step. I will go to the table product v2, which has more or less exactly the same structure as we had in the past as the product table. We are going to create view. We are saying insert, update, delete statement. And we rename everything here inside our objects to be now product BD for VD product. I show you the existing implementation. Product is the name. The before insert should also be product and before update. And before delete, I changed already. Before delete is no longer VW. This one is no longer VW. This one is no longer VW. And the full view is now exactly the same name as the original procedure. Let's compile that. And the interesting thing is now we still have the possibility to do a select statement from product from an old application with existing source code that is hard-coded, that you do not want to change on your own. But technically, it is simply working on a view, and the view is now working on the new implementation of the application. And the table has now a very different implementation. There are very different columns. Could be, for example, that we have new columns, that we have existing columns coming from other tables or so. But we still have the compatibility level to the existing applications, that we simply replace the existing table by a view that is now connected to the new table. And we still have the possibility to run the same application without changing the application source code. We had a real-world solution from that, where we have used that on a customer database, the German press agency. They are responsible for a lot of German newspapers and also for European newspapers, like Associated Press or Reuters or so. It's a similar kind of company. They have approximately 1,000 employees, and 800 of them are writing editors. And they are using a piece of software which was implemented based on the Firebird database server. And their main database had approximately 65 gigabytes of data inside. and approximately 95% of the database was one table. And in the original structure of that database, the table was called star document. That was the internal name that was given to the table by somebody who was responsible for the existing database model. And over the years, when they developed that, they started with Interbase and later changed to Firebird. And it's really a very interesting project. They have approximately 3.5 million records inside that table, where all stories that were written by any one of the German press agency editor team is stored directly in that database. We also implemented there a very complex replication system, also based already in that time on Firebird 2.0. I was in that company on the 12th of September in 2001, and the day after 9/11. And it was really an interesting experience because it was really high load on the database server, because everybody from the German press agency team tried to do some researches on the existing stories and find out what happened really. And it was really an interesting day in my life. I never forget that. The interesting thing was they had a single table, which was approximately 95% of all data inside the database. And it had approximately 240 columns. And the basic problem was, if you're doing something like a select statement, select star from product, for example, or make it from customer, it is important to know it does not change from the I/O perspective if you do this or if you do this. Because to find out the ID value, it has to load the full data page from the I/O subsystem, also from the hard disk or SSD, and extract the column that you want to see. If you have computed columns, it can be even more complicated, but it does not change anything from the perspective. If we, for example, have a look at this SQL statement and go back to the SQL statement here again, and we do the execute and fetch all. In that way, we see here it was reading 164 pages from disk to cache. And when we try to disconnect and reconnect again, and we read all columns, it is exactly the same amount of data. So from the I/O on the server side, I/O between the server CPU, the Firebird process, and its local drive, it does not change anything. Over the network, it's much less traffic when we simply only transmit the data that we really want to see. But the problem in that moment is when you want to have, for example, only a list of, let's have for example, email and ID somewhere. ID and email. And we just want to have stored this data somewhere. Let's do insert into customer email or something like that. Yes, it should commit existing data and create table and put the data into that. And if we, for example, now disconnect and reconnect and say from customer email with execute and fetch all, we see here we have only 47 pages loaded into disk from disk to cache. And in the, you can imagine, for example, the problem at the German press agency was we had not only 20 columns, we had 240 columns. And it was a lot amount that was read from the disk, even by simply trying to read, for example, the newest messages which contain in the title, for example, Osama bin Laden and George W. Bush and whatever. It was a lot of data to load from the disk. And it was approximately almost 20 years ago. So we were not in the timeline with SSD or something like that. It was much slower at that time. And approximately 800 people on 3 different cities were working on such databases. So it was also a very big amount of time that was wasted waiting for the result set. One of the results that we implemented there later was really simple. We changed the star document table with approximately 240 columns into 4 different tables. There was something which we called a star document master, which was only a title name, a date, timestamp from the story, the author, and the main area where the story is about, for example, sports or politics or whatever. And the second table we used, the first table had approximately, I think, 10 columns or so. So similar to this one, very, very few columns and only the basic data. And the editor who wanted to do some searches inside the database was typically only working on that table. And the second table had almost all the other 200 and whatever columns. But the result from the second table was only taken to the first screen on the editor's box when he was searching for a specific content of a specific story. And we had table number 3 and table number 4, which were for full text search engine and also for the RTF code of the database. And it was really important for them to have a result set on almost each search on their application in less than 1 second, even over 3.5 million records inside that table. And we made that in that way. So we simply replaced the existing star document table by a new table, star document master, second table, star document data, third table, star document FT, like full text, and fourth table was star document data or docs or whatever it was called. And but the problem was one of the applications that was already implemented in that environment was a importing tool that was connected to a satellite device. And for example, if Reuters news agency will send some data, they send it over a satellite link to DPA and vice versa. And that code was directly based on the original star document table with all the 240 columns. So we decided to have a star document view, an updatable view, just for the possibility that nobody wanted to change the existing importing tool for the satellite link, because the satellite link programmer was no longer active in that product, and the source code was written in really ugly C++ source code. It was really unreadable also for professional C++ programmers. And the main responsible developer on that team always said he do not even want to open that source code again. Can't we do a kind of a interface inside the database so that the old application can still work on the existing code, because that's only some insert statements and nothing else. But each insert statement will always have 240 columns, or a big subset of all these 240 columns. And it was really easy to be implemented in that way. I more or less showed you a few minutes ago. And the updatable view, the triggers, for example, here, were then really simple. And when you have a look at, for example, the insert or update trigger, the update trigger was not only one update statement. In that case, we had, for example, 4 different update statements. So if, for example, the specific column was changed, we update that on this table. If another column was changed, it could be that we are updating that on a different table, and so on. So I think it could be a very interesting basic idea if you if you no longer like your own database model, I know sometimes making a database model 20 years ago, you will hate that for the next 20 years, and also for the next 20 years you will hate that because you made stupid decision in that time. It's often a very good idea to replace existing stupid metadata decisions by a new table construction and replace the existing object simply by a kind of an updatable view to have your existing application still working as you need that, but your new applications are really more powerful and have a completely different database model. I know from one company where we have seen a phone number 1 until phone number 9 column in a customer table, and the phone number 1 until phone number 9 table column to be connected to a TAPI device, telephone API device, is not really nice. So it was really a very ugly implementation. And we also decided there to have the original application to display this amount of columns inside an updatable view, so everybody can read the data, but also can write down the data in the old application. But the new application had a separate master detail relationship to table, the phone number tables. But the old existing applications do not want it to be updated because it would be too much work. A lot of reports were directly connecting to the customer table with the name customer and the specific name of that column. And a lot of these reports were done dynamically. So it would not have been a good idea to work on that database model any longer in the same way. But the existing application worked really fine on that replacement of an updatable view. So I think I gave you some basic ideas what could be possible in the future when you are thinking about your existing database model and how to improve your existing database model and also improve your existing application simply by doing some, perhaps decisions, implement views with column-based functions or with column-based stored procedures. Can be also done by stored procedures to show data or not show data. And as you can imagine, for example, if you are working with an application now on this kind of data, and you write down inside your Delphi source code a relation, a data source, data set, T-field relation to this column, you do not have to change anything in your code. You can simply write down any record exactly in the same way as you did before. You can simply read in any DB grid or in any DB edit column. You can use exactly the same technology, but you have on the server side the decision if the end user can see the data or not, or should he see, for example, only parts of the data as we implemented that here, or does he do a completely different implementation? Could also be a possibility. We often have very, very complex columns. So, for example, if you have a production order inside an application, and you need to understand, for example, on the first view, how many % of this production order is already manufactured at the moment. If you want to try to read that value in runtime for 35 records, you need to have a lot of operation and a lot of SQL statements on the database server. It's almost impossible to have that data in runtime, but it's really an easy implementation. If you do not have it in runtime, you simply put it into a function or into a result of a stored procedure. And the result of a stored procedure is placed, for example, as a result set, like we had here done in the view, the top 100 sales view. For example, if you want to see the percentage of manufacturing completion of your production order, and you see, for example, it's 98% or 97% or whatever. If the value is perhaps 2 minutes old, it is almost already so perfect then compared to other applications which have the value of last night or something to only shown to you. So it's also a very easy way to improve the quality of your application display without making your database server exploding. Because when you're doing stupid decisions, and you will see the stupid decisions here inside the Trace API session really fast, and also perhaps inside the database monitoring, it could display you some of the inserted, update, deleted, selects, non-index reads, index reads, and so on. And you will definitely see that some decisions which were made by simply calculating some values on the fly are really stupid decisions, and you will hate that when you are working with larger amount of data. But I think there are very good workarounds which make it possible for you to improve the application on the Firebird server side already and display it as the Firebird server already decides on its own to display the data or not, or to filter the records or not. And filtering records is always some of the things I always explain to people. You can also ask, you can phone up your telephone provider and ask them for a phone number of a specific name on a specific city, but you will not want to have them read the full phone book to you. You will ask them a specific question and he will give you only a result set. That's the basic idea you should also have in mind also for a database application. Do not display everything and let the user decide. Everything that you are doing inside a filter property, inside Delphi, for example, always have in mind that most of the filter technologies inside Delphi are really horrible, stupidly implemented and make your application extremely slow with large amounts of data. So always have in mind that you need to improve your application mostly, and not only the database. It's a combination of both. I think for today was an interesting session, wasn't it? I changed a little bit the topic, but that's always the way how we do it, and we really like to do that. And yeah, if you have some additional questions, I will now stop the video. And you can download the video again tomorrow, where you have again the possibility to press on the pause button and rewind and ask for that again. And goodbye, enjoy the holidays if you have some. And I think we will announce some more sessions end of August or so. And really nice to have you here again, and let's see when we meet back. Bye-bye.